Hey Math 1B, I've got a new video for you starting chapter 4. It's very different from what we've been talking about before, but I think you'll see there are still some similarities. It's called Polynomials. That's the overarching title of the new chapter. The first thing I want to start off with is just how to classify polynomials, determining whether or not an expression actually even is a polynomial, and then identifying it as a mono, bino, or trinomial. So, what do I mean by the word polynomial? So, polynomial basically just means polynomials are all algebraic expressions, that just means expressions involving variables, yeah? Except, and here are the two big exceptions, except ones with negative exponents or variables in the denominator of fractions. Or variables in the denominators. So let me just try to translate that for you very simply. Can you guys see that whole thing? Yeah, you can. So 4/3 x squared plus 2x minus 3. Is that a polynomial? Yes. Because there are no negative exponents and there are no variables in the denominators of fractions. Now, I see a 3 in the denominator of a fraction, but last time I checked, 3 is not a variable. So, we're good. Two over x plus 7x to the third power. That's not a polynomial because there is a variable in the denominator. Two xy squared plus 3x. Yes. Because there is no negative exponents. This one? No, because there is a negative exponent. All right, so I've given you 4 examples already, but let's just run through the notes to be thorough here, okay? So is this first one a polynomial? Yes or no? Yes. Moving on. Part B. Is that a polynomial? No. There is a variable in the denominator. It violates the terms of the polynomial agreement right there. No. Oh, this is an interesting one. 18. Does 18 have a negative exponent? No. Does 18 have a variable in its denominator? No. It is a polynomial. Tricky. All right, and then check D. Negative exponent alert. No. Letter E looks just like the first example I talked about earlier in the video. All positive exponents, no variables in the denominators of fractions. This is a yes all the way. And then over here, this one kind of looks like that third example I did over there with positive exponent, positive exponent, positive exponent. Nothing but positive exponents. We've got a yes polynomial. All right, so yes, no, yes, yes. Now, what's this other part? If so, identify the polynomial as monomial, binomial, or trinomial. Now, normally if I'd have you guys in class right now, I'd just ask you to guess and see if you could figure out the pattern on your own. But we're in remote learning, so you can't do that. So here's the deal. You got two terms here separated by a plus or minus means it has a new term. So two terms, mono, bino, trino. It'd be binomial. Bi is the prefix meaning two. So this is going to be a binomial. There is no classification if it's not a polynomial, so you can just skip that whole thing. Do not put binomial. It's not a polynomial. So don't try to say it is one. All right, this one, there's only one term, which means it's monomial. And then down here, again, it's not a polynomial, so don't classify it as such. This one has 1, 2, 3 terms. We would call that a trinomial. Oh, what do you guys think about this one? Is this one term, two terms, or three terms? Well, the multiplication makes that one term down here. That a squared b cubed, that's just one term, two terms, bino. So it'd be yes, it's a binomial. All right, so classification, pretty straightforward. Sorry if my explanation was a little clunky. Didn't intend to do that. All right, now let's talk about something different. Degree. What is the degree of a polynomial? The degree of a polynomial equals the product of the powers of the biggest term of the polynomial. Yikes. Okay, what is that supposed to mean? Well, it basically means the degree of this polynomial is 7. The degree of 3x to the 7 minus 8x plus 2 is 7 because this term right here is 3 times 1, 2, 3, 4, 5, 6, 7 x's. So this has 7 powers to it, which means product multiply, right? Product of powers. The biggest term of the polynomial is 3x to the 7th. Its power is 7. So this is degree 7. How about this one? That's degree 2. And we can just use D for that. Because this is the same thing as 9 minus 3 times x times x. There's two variables being multiplied side by side. Now this one's a monomial, so everybody's connected through multiplication on this one. This is negative 3 times x times 1, 2, 3, 4, 5 y's. It has a product of 1, 2, 3, 4, 5, 6, 7 powers. So that's the degree 7. Are we picking up on this yet? Maybe. Let's see here. So try to think this through on your own. Pause the video and see if you can come up with an answer for this. All right, let's see. Well, each individual term you have, this is m, m, n. So this individual one has a degree of 3. Right here you've got mn. That's going to be degree 2. This one's going to be m, 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 m. N. 6. So, what's the product of the powers of the biggest term of the polynomial? It's degree 6. All right, the last one's a special case. If it's just a constant, if it's only a constant, just like 9 right here was a constant, the degree is 0. All right, so we talked about classifying polynomials, yes or no. We talked about if it's a polynomial, is it a monomial, a trinomial, or a binomial? And then we just talked about the degree of each polynomial. Last things we're going to talk about are going to be leading coefficient and degree. I didn't mean to put 4 and 5 down here. That's why I kind of had a dumbfounded look on my face. That's one of the reasons why, at least. So, yeah, number 3. Disregard number 4, please. Disregard number 4. You'll see that on tomorrow's video. All right, so write each polynomial in standard form. So maybe they're not in the right form just yet. Identify the degree. Check. We already know how to do that. And then the leading coefficient. We haven't talked about that yet. So first of all, standard form. Another way to talk about that is descending order. Which means biggest power to smallest. All right, so the biggest power is 8x to the 5th. So what I'm going to do is I'm going to rewrite it using the commutative property as plus 8x to the 5th goes first. Then I'm going to take the next biggest power. Negative 4x to the 3 would be next, and then a positive 6x would go last. So this is technically standard form right here. Now, what about the degree of the polynomial? Well, we've got degree 5, degree 3, degree 1. So the degree is always going to be the exponent for the biggest power in there. It's always going to be lead off. So it's going to be degree 5. What's the leading coefficient? Well, the leading coefficient is going to be the number multiplied to the leading power. That's 8. So the leading coefficient is positive 8. And we're done with part A of number 3. Part B, the biggest power is x to the 6. So that's going to go first. So when we're talking standard form, it's going to start out with negative 2/3 x to the 6 because we're talking biggest power. Can you guys see that? It's really bright. Biggest power to smallest. Biggest power. The next biggest power is 7x, and then plus 16 would be, that's a degree of 0. So there's our standard form. Our degree, 6. Our leading coefficient. Look, a lot of students will want to say it's 16. Our leading coefficient is the number in front of the leading power. It's negative 2/3. All right. Last one. Pause the video and see if you can do this on your own. Okay, let's check it out. Standard form. Biggest power is x to the 3rd, so I'm going to go minus. Make sure you carry the minus with the 6, x cubed first. Negative 4x squared would come next because of the 2. The 2 is bigger than the 1 here. And then it's a positive 10x. There's standard form. Once you have it in standard form, you just look at the exponent for the leading power. The degree is 3. And then the leading coefficient is that number out front, -6. All right, hey, you guys have been a great audience. Thanks for paying attention for the full 15 minutes and 15 seconds. Hopefully it was helpful. And yeah, please email me if you have any questions at all.